Hello and welcome to the latest webinar by Bit Gardener. My name is John Kowalski. I'd like to welcome you. I'm part of the marketing team here. Today's office hours, that's what we're talking about today. We're talking PELT technology, multi-layer film thickness. If you're unfamiliar with the office hours format, it's a shortened presentation, usually 20, 25 minutes, and then the rest of the time is yours for questions, discussions, to talk about any challenges you may be facing in your facilities or with certain applications. We got some technical experts on the phone here with us today. Also, we are recording this, so immediately following the presentation, you'll receive an automated link to that recording. Feel free to share it with colleagues, check it out later, grab some screenshots, whatever you like. And also know if you have any questions after the fact, you can simply hit reply to any of those marketing messages. It'll come to my team and we'll funnel it to the appropriate technical specialist. So with that, our presenter today, Miss Renee Bassett, she's product manager over at PELT Ultrasonic. Welcome, Renee. How are you?
I'm good, John. Thank you. And welcome everybody who's with us this afternoon. I will get started. So again, thank you, John. My name is Renee Bassett. I have been working with PELT for about 25 years now. So I am your resident expert. So I'm going to start today with the introduction to PELT technology presentation, and some of the things, if you are a PELT user, will be very familiar. For those of you that this is brand new information to, please jot down any questions, like John said, and we will get to them when we can. So I will start right off here. All right, so PELT is an acronym. It stands for Pulse Echo Layer Thickness, and we measure your film build layers by using ultrasound. This was first introduced into the automotive industry in 1994, and PELT is currently the highest resolving power ultrasonic thickness gauge on the market. The industries that are mostly served with PELT, of course, are automotive. We also measure wind turbine blades. We do quite a bit of different things in the aerospace industry and also shipping containers. Other industries, we can measure wood samples, glass samples. There's a lot of different applications that PELT can be used for. Some of our typical automotive customers, you can see here, this is just a small example of our automotive users, but not only the major OEMs, but we also are widely used in the plastic add-on markets, fascias, bumpers, mirror cowls, that area. And what the capabilities of PELT are is, first of all, it's non-destructive, and we measure every single layer individually and simultaneously at the same time. So we can give you an individual film thickness layer. So if you need your top coat, we give you top coat, mid coats, primer coats, and then we also can give you a total thickness, all with one measurement. You don't need any specially prepared panels. You don't have to tape off any bodies. You don't have to do anything special. We take the measurements right on your finished product. And we measure all types of coatings. This includes any applications that are wet and wet, or even the 3-wet process. So you don't have to have each layer cured in between in order for us to take measurements. The final product has to be cured, but the process of applying films wet on wet, once that is complete, we can measure each layer individually. And we can measure on virtually any substrate material, plastics, composites, like I said earlier, glass, wood, steel, any of those type of materials. So PELT is also a great diagnostic tool. So taking PELT measurements can help you improve your process monitoring and control. We can map the spray patterns and uniformity for any robotic spray patterns, and that can help identify any thickness related defects such as solvent popping, off color, and those type of issues. So what PELT is, it's basically an acoustic microscope. That's the way we can best describe what PELT is. We have a transducer probe, as you can see here, with a black flex cap on the top, and we put a drop of glycerin between our transducer probe and inside our cap, and then we spray water down on the top of your finished surface, and that's to allow the sound to transfer in through the coatings. It's very similar to when if a pregnant woman was to go to the doctor, get an ultrasound, they put the gel on her stomach before they use the probe wand. It's the same idea. We put water on the top of your finished product, and the sound will then go down through each coating. And when it hits a layer boundary, the sound will reflect back up into our transducer. So the gauge is sending out pulses of sound, and that it goes down, hits a boundary, and comes back. So it does that all the way down through every coating layer until it hits the substrate. And what that does at each one of those layer boundaries, we get an echo signal. And that echo signal, we have a couple different ways of describing it. Most commonly, we call that an M shape. So if you can think about this as looking like an M or a W shape. We also can call this a negative or a positive, or sometimes a valley and a peak. Whatever makes the most sense to you when you're looking at the shapes, that's what you're looking for, shape recognition, an M or a W. So if I was to take this same microscope image that I showed you just a couple slides ago here, and you can see that this is the waveform output that you would see. This is like the display you would see on the PELT gauge. And as the sound goes through our coatings, so this is our first big echo, and this is a little different than the M and W I just said. This is what we call our shim echo or our first echo. And the echo starts here right at the boundary between our cap and the top of our first layer. And then as we hit this layer boundary, we get an echo here. And then we hit our next layer boundary, get an echo, third layer boundary, an echo here, and our fourth and final layer here, our echo boundary before our substrate. Now, what's nice is that when you purchase a PELT gauge, we provide calibration files for you based on your samples, and we tell you what to expect for these echo shapes. We never expect you to have to guess or try to figure out what the echo shapes are. We let you know ahead of time by giving you a guide wave. So we would tell you that here, so for this exact color, if this was, let's say, a white, our tape 2 here looks like a base coat of white, perhaps, that we would say, okay, so we have our shim echo, and then we have an M or a negative between clear and base. We have a positive here or a W between our base and prime. And then we have an M or a negative here between prime and E-coat. And then our substrate echoes when on steel substrates are typically an M or a big negative. So again, if I was to take that waveform and then superimpose it right on our substrate here, we can see this again. And the principle of our method of measurement here is what we're doing is we're measuring the time of flight or the sound speed. So the time it takes to get from this area to our first marker, our first interface, is a set amount of time. And then we're able to determine the layer thickness by the velocity of sound multiplied by the time it takes, and then we divide that by 2 to get our thickness. Now, the velocity is determined by the calibrations. What I was just saying about we let you know what the waveform looks like. We also are able to determine that how much time it takes, what the velocity is. So the layer thickness is determined by the velocity of sound, how fast is it traveling, multiplied by the amount of time divided by 2. So here you can see, again, this is a very typical automotive 4-layer coating. So here we can see the top was our clear coat. This took 48 nanoseconds, and that came out to 53 microns. Base coat was 18 nanoseconds, 22 microns. Primer, 58 nanoseconds, 73 microns. E-coat, 20 nanoseconds, 27 microns. One of the big differences between using a PELT gauge versus a magnetic induction gauge is that you don't have to take subtractive measurements in order to get your multi-layers, and it also, you don't have to subtract out the zinc and phosphate. So a PELT gauge, when calibrated and you use that calibration and take your measurements, we're going to give you a true E-coat only thickness and the individual layer thickness, all from that one location. If you were to compare PELT measurements to a magnetic gauge measurements, you would see that the thickness of the E-coat would be more on the magnetic induction side of the gauge measurements, because it would include that pre-treatment, the zinc and phosphate, whereas the PELT gauge, true E-coat only. Also, because the PELT gauge is taking the measurement all in one spot, with the magnetic gauge, you have to move over and take subtractive measurements, and that can also bring in a little bit of error because you're not measuring all in the same spot, and the E-coat thickness or prime thickness could have varied between those spots that you're jumping across. Now, the coating calibration process. This is what makes the PELT, one of the reasons the PELT stands out amongst other ultrasonic gauges, is because when generic calibrated velocities are given, or just generic velocities in general, not calibrated velocities, you're getting an approximate thickness value. So we ask, when you purchase a PELT gauge, that you would send us a sample. It can be a cutout of plastic. It can be a full build panel. This image here shows masked panels. We no longer require masked panels. You can just hang a panel, or if you have a scrap body, as long as it's a first run, cut a piece out of the scrap body. And then we will do a one-time destructive test on those samples. And we use a microscope and also a magnetic gauge to get actual thickness data of each layer in that film build. And then we generate those velocities I was talking about from those test panels. And it is important that you would use every base coat color should be calibrated, or every coatings film build you have. So if you're non-automotive, if you may only have 2 or 3 different film builds, it's important that you send us a sample of each one of those film builds, and then we would provide you these calibrated velocities. So we'll give you a software file that can get loaded onto the PELT gauge. We give you the certificate for each of those calibrations, and then we give you the guide wave, that thumbprint wave that I was saying, that tells you if it's going to be a positive, negative, or M or W for each of those individual echo shapes. And we recommend that that you recalibrate once every 2 years. And that's a recommendation only, because we want to make sure that nothing has changed. You would absolutely want to recalibrate if something changes, such as a supplier or a material. You would definitely want to send a new panel in and have that recalibrated. I got a little bit ahead of myself here on my slide. So again, like I said, calibrations are certified, recommended, certified every 2 years. Recalibration is necessary if a supplier or coating type changes, or perhaps it's part of your quality system requirements. You have it in your quality system that you are to recalibrate your colors every 2 years, or in whatever time frame you specify. All right, there are no usable adjustments for calibration controls. It's not unlike some of those magnetic induction gauges where you have to zero out or calibrate on a known thickness shim. You do not have to do that with a PELT gauge. We offer this product here, which is a certified shim. Now, it does have a known thickness, and we provide you a calibration file for it along with a guide wave. And we would say that it's up to you on how often you measure this certified shim. You can measure it once a week, once a month, or only if you think possibly, wow, I think there might be something going on with the PELT gauge. The numbers I'm getting when I take measurements, something doesn't seem quite right to me. You would use this like a sanity check, like, oh, I'm taking measurements on this shim and I'm hitting that number. So, okay, maybe there is something going on in my process, or I need to talk to a technical service person with BIC and just make sure everything is okay. So you would use this just for more of a sanity check. Taking a measurement on here does not adjust how the PELT gauge takes measurements. The gauge itself, the hardware, we recommend to be certified every year. You would send that in to a BIC office for certification once a year. And then we can also have a loaner be made available for the loaner fee when available. And then also, if any small repairs are needed, those all get done within that certification price. If you've cracked your display or the display looks worn, we would recommend that the screen gets replaced, and that would be something that would be an additional charge on top of the gauge certification. All right, so if I'm going to take measurements with using this PELT gauge, I can go out and take one measurement, and then I can mark it right on the display and get my information right away. I can see what the thickness of each layer is. I can also see a total. So this is great for spot checks. You can take it anywhere in your plant to take these measurements. But also what's really nice about the PELT gauge is you can take multiple measurements in a relative quick amount of time, and you take a measurement, you capture, and you keep going. And you can take, we have some customers that take daily measurements, maybe 30 to 50. And we have other customers that take like an audit measurement sequence, and those can be 200 or 300 locations. And then all of that data gets uploaded onto your host computer, and you use a program called PELT Manager. And you can have the PELT Manager program go through and place the markers, so you don't have to painstakingly move all these red lines on the boundaries, the echo layers, and it will place the markers for you, and that also will save time. And then we just ask that you go through, review every single waveform just to make sure the markers are in the place that you expect. And then you can take that data and analyze the data in your own programs, or then also in Smart Chart. So here is a screenshot of the PELT Manager software. The data is transferred through USB, so it's fast and reliable. And you could transfer just that one location or several locations, as I said. And then the automated wave analysis using the Auto Gauge 2 to place those markers. Now, what's new towards the end of last year and that we're happy to announce is now the PELT data is smart chart compatible. So this will provide you standardized test reports for a single vehicle or a single part or maybe a rack of parts, and you can define your own SPC reports, thickness variations for selected check zones over time for each layer and total thickness. The color calibration files can be directly imported, and you can set your pass-fail limits for each layer. And then you can define your organizers and standard operation and clear simplification, identification. And what's also great now is that you can take the PELT film build, your Bic Mac film build, the wave scan for orange peel, and they're all in the same database. It kind of closes the loop for all of your process monitoring. And then once you purchase a PELT gauge, we don't feed you to the wolves. We're available. Your sales team, the technical team, we provide on-site training. We'll give you some email support, online support, phone support, whatever you need. We're available to help you for whatever you need. And that concludes my presentation. So thank you all very much for your attention. And now if there are any questions, I think John will help with that.
Yeah, good stuff, Renee. Really interesting technology, using sound and going through those multiple layers. And if anyone has questions, challenges that you're facing in your own facilities, just drop them in the chat here. We'll get to them. I have a bunch here. I'll just start rattling off if you're good with that, Renee.
Absolutely.
All right. First one. What is the minimum layer thickness that you can accurately measure, and particularly for challenging applications like adhesion promoters?
Okay, great question. What's also great about PELT gauge, and now that we are part of the big family, is that our transducer technology is improving all the time. And now we have our standard transducers. We used to give a minimum of about 8 to 10 microns, but with our newer transducers like the 40B transducer and the 50B, we have definitely broken through that, and we can get down now to under 5 microns. But if you do have a challenging application such as adhesion promoter, what we would ask is if you can send 1 or 2 high run samples so we can just verify quickly that we can measure those layers. We might be able to measure all of them. We might be able to only measure a couple of them, but we don't want to absolutely say that a 50B transducer is going to solve all your low thickness measurements, but we certainly want to work with you and be sure that we can do that.
Great. That's a great thing about BIC, whether it's the PELT technology or other instruments. We're always happy to run samples to prove out the technology, to show you exactly how it works and work out any challenges that may pop up. So that's great. Let's see, how does the PELT technology differentiate between adjacent layers with similar material composition?
So also an excellent question. So when we have 2 layers that are adjacent to each other and they have similar properties, what we're looking for is the difference in acoustical property. If the difference in the acoustical property is large, we get a nice big defined echo. When the materials are more similar, we get a lower, more of a flatter looking waveform. And what is good is with these new transducers, not only can we now break down and get into lower film thicknesses than we can before, but we're also increasing our ability to resolve those layers. So we're now starting to see those layers that have similar properties. We're starting to get a little bit of a taller waveform. So I would definitely, if this is something that you're seeing right now and having issues with really trying to find where that waveform is, to let us know, reach out to us. and we can take a look at your samples with our newer transducers, and maybe we can start to resolve that similar property
Okay.
interface.
Nice. Is there a maximum number of layers that can be measured, simultaneously?
Right now,
Yeah.
the calibration limit is 5 layers.
Okay.
However, if you have several repaints all in a row, we can always give you a total thickness. And if there's a specific combination you want calibrated, as long as it's in up to
Hmm.
5, we can combine a couple of those layers. But we can open up that window and we can measure a total film build, for quite a few layers. You're going to see every echo. We just we can only calibrate. You only get markers for up to 5.
Okay. Okay, good. Now, what about measuring on textured surfaces or substrates? And then I also got a question in here about multi-layer thermoplastic films for like food packaging.
Sure. Okay, 2 great questions. So textured materials sometimes can give us a little bit of a problem because what's happening is our transducer needs to lay touch at a 90-degree angle to our surface. And what happens is if there is a textured surface that has really deep gouges,
Yeah.
when the transducer is placed, when this sends a signal down, if it hits at an angle, the sound is not going to come back up straight into the transducer. So that can give us a little bit of problems. We can measure a very mild texture grade, but again, if this is something that you have interest for, again, please send us a sample and we'll let you know
Yeah.
if your texture is too deep or if it's something right at the limit where we can measure. And as far as the thermal grade packaging, we have taken measurements. We've had customers ask us this before, and as long as a lot of times those layers sometimes have like a air gas between, but as long as those thermal layers are sandwiched and there's not an air gap, the PELT can measure those with ease.
Wow. That's cool. That's cool. What's the craziest thing you've been able to measure with this thing?
That's my favorite question so far.
Okay.
It's a toss up between a gobstopper and a malted milk ball.
Really?
Yep.
Gosh, okay. So, all right. So you're doing food applications like that then?
Well, we were playing around, what can the PELT
Okay.
measurement, right? Like, what did we have
But
in somebody's desk? Oh, we've got candy. Let's give it a try, right?
but it works. That's
It
crazy.
works. Yep.
That's crazy. Question in here from Robert. How many different recipes can the unit store? Or standards, I assume.
Sure. Right now that we don't necessarily have an upper limit of how many calibration files that you have on the gauge.
Okay.
We have a pretty beefy SD card in the gauge. So I think that, we have customers that have taken calibrations and we've seen up to 100 or more calibrations files in the gauge. It's when you take, um, if you start storing measurements that you've taken that have 500 or 600 points, and once you get a few of those on there, the gauge might slow down a little bit. But that's
Uh-huh.
the measurement wave files, and once those are loaded into the computer, then they can be deleted off there. But calibration files, we really don't have an upper limit right now.
Nice. Very nice. Very nice. Keep the questions coming, folks. Just drop them in the chat here. Yeah, we got lots of time left, so this is good. Let's see what else. Can you explain the difference between the low energy and high energy pulses in the different models and when each one would be preferred, whether it's based on an application or a different set of circumstances?
Sure. So the automotive uses our standard HE pulsar with the high frequency transducers like the MB, 40B, 50B. Those are what's used for our automotive coatings. If you were to measure a coating on like a shipping container sample that
Yeah.
has a blasted substrate with the zinc blast, and those layers are pretty thick. There's the top coat, intermediate coat, and then that zinc coat. Those are pretty thick. So what we do then is that would make a customer need a 3H gauge or the 5 plus, where the 5 plus can have the low energy pulse and the high energy pulse. So that would bring you into the high pulse, the 3H. And then we would use a lower frequency transducer like a 20B. And that will, applications such as, like I said, the shipping container industry, and we would use lower frequency transducers on the wind turbine blades, or anything that's really thick materials. We would want lower energy, higher energy and lower frequency transducers.
Okay. How effective is this when measuring different materials with varying densities?
Well, if the materials with varying density, that's
Yeah.
actually better for PELT, because that's when I was talking about that acoustical contrast.
Yeah. Yeah.
If the layer density, so for example, like a white solid is next to a primer or a clear coat, it gives a huge echo because there's such high solid content. So
Okay.
the bigger the densities are, the better it is for PELT, because we get a nice tall peak on our echoes.
Okay. Okay, nice. A couple questions I'll combine. You mentioned the glycerin. You put that on the surface before the measurement, or the water. Can you explain the process? Does someone need to have that bottle of water or glycerin on hand to prep the surface prior to every measurement, or how does that work?
Okay, yep. I can definitely talk to that point. So the glycerin, we put a small drop of glycerin in the cap and the transducer again, and that's to let the sound penetrate through into the through the cap material, and then it should only have to be applied maybe once a week or once a month. If you just for maintenance purposes go in with a lint-free cloth, clean out the inside of the cap and the surface of that transducer. Crystal, we want you to use a minimal amount of glycerin as possible, because as we know, in a paint shop, glycerin is a no-no, right?
Yeah.
I mean, we don't want to, of course, we are taking measurements on finished surfaces, so not in between. So it's not necessarily that big of an evil. But then we use water on the surface, and you would want to have like a spray bottle or a dropper with you next to your gauge, so you can prep the surface. Sometimes we have, our customers operators know the pattern by heart, so that if you're taking 5 measurements on a door, they'll spray those 5 points and stick the trigger bottle in their pocket, hang off their pocket of their paint suit, and then take all 5 measurements, and then take the sprayer out and keep going. And one of the things that's nice about water, especially if you use like DI water, is that it's easy for cleanup. And then once you release, if it's a vehicle body, then it gets released, and it's usually going to dry off before it gets back on the line.
Is there a type of recommended water to use? Is it distilled or?
It can be anything like that. Whatever is the easiest for cleanup. We don't have a specification on the water. One of my little anecdotes, I say one of my favorite things I did in a demo once, we didn't have water available, so I actually used coffee on the
really?
samples. It was samples I brought, not the customer samples.
Okay.
But,
I was going to make a joke. It's like, what? No flavored water? But okay.
No.
Okay. All right. Good. Good. A couple more questions in here from Daniel. My question relates to co-extruded films composed of unpigmented olefins, PE or PP, and tie layers. Have you looked at any of these types of films?
Not to my recollection. If my calibration lab person was here next to me, she would know that probably better than I would. But it definitely, there was nothing that was said that sounds like it would be a problem. So my recommendation would be, please send us a sample. We'd love to take a look at that, and we would we could make a feasibility report for you on that. That sounds like a really wonderful opportunity.
Yep, absolutely. Absolutely. Yeah. So, Daniel, feel free to, hit reply to any of the marketing messages or reach out to us and
Yes, please.
we'll get a sample of yours and do some testing for you. He's also asking, how long does a typical measurement take?
It can be as quick as, 3 to 5 seconds per measurement.
Nice.
If you're in a location that it's starting to get a little bit curved, the
Okay.
operator might have to, steady their hand a little bit better, but measurements can be fairly quick. It very, very quick. Just, for measurements, like I said, maybe 3 to 5 seconds per
Yeah.
measurement.
Okay. That's quick. Um, Now, regarding these instruments, are they typically used out in the manufacturing floor, in a lab, both? Question is about durability of these things.
Yes. Yes, the answer to that question is both.
Okay.
We have gauges are used in the QC in a lab or out on the production floor. But some of our non-automotive customers, again, I'll reference the shipping container industry. That is probably one of the hardest environments we've seen PELT. And they come in for certification, and we see a lot of like salt, on the
Yeah.
inside, salt corrosion, and it doesn't, we clean that up, but it doesn't affect how the gauge is, how it's performing. So that sees a very humid, and then cool off, go into an office with air
Yeah.
conditioning. So it's going back and forth in those pretty crazy environments. So yeah, we see this everywhere. I mean, I think the biggest thing we see is if something gets dropped right on the
Yeah.
display will get cracked. But that is really the biggest problem that we see. And that's any instrument, right? So
Yeah. Yeah.
yep,
Definitely.
in the lab, out on the floor,
Okay.
out
And
in the hot sun.
it handles the temperature changes, from like in lab
Yes.
AC area to, something that's, has a little more humidity and heat out
Yep.
on the manufacturing. Okay, that's
Yep.
one great thing about all the big instruments. They seem to just handle those temperature changes really well. So that's great. That's great. Um, can the measurement data be integrated into existing QC programs or systems?
Absolutely. The way it's the CR, oh boy, I'm going to say this wrong. The data that comes out of the PELT gauge is,
CSV file?
yes, thank you. Just
Yeah,
for
no
a
problem.
half second, I just glitched there. Um,
No
and
worries.
that we have a lot of customers that have their own databasing systems that can import that data into their own systems.
Awesome. And I know you also offer a robotic system, yes, for putting on like a
Yes.
killbot or some other type of robot. Can you touch on that just a moment?
Absolutely. So what's nice about PELT is we do provide a robotic PELT system. It can be mounted with one or two arms and transducers. And what's great is that can be put on the same robot arm as the other big instruments. So it's
Cool.
pretty fantastic. It takes the measurements. It automatically will spray a little bit of the water, takes the measurements, it goes right
Ah,
to the computer. Everything is automated, and yeah, it's pretty fantastic technology.
so it'll even spray the water and prep the
It even
surface.
sprays the water and then
Oh,
kind of blows it a little bit, so it
nice.
makes little droplets.
What do they think of next? I
I,
tell you. um, with if someone's out there that has an older pelt unit, what's the advantage of upgrading so they can, you know, use the new version with the big smart chart software?
oh yeah, sure. So if you have one of the older PELT gauges, like the ones that are in the leather case, um,
Yeah,
though your gauge is probably 20 years old or getting up there in age.
yeah,
And what's that old PELT gauge? It although it can use the new transducers, you will not see any benefit of those new transducers. The
okay,
digitizer in the handheld, or the new PELT gauge with the touch screen, the digitizer is way more advanced. So that allows us to use the higher frequencies of our newer transducers. The other advantage of the touchscreen gauge is that it uses the USB transfer. The older gauges are still using serial port, so you probably have to use a dongle cable with the USB, and it still transfers at serial speed. Very easy to get corrupted and have issues. So we are offering a trade-in, 20% with if you trade that older gauge in towards the new gauge. Now there are a handful of customers out there that have the touchscreen gauge, but it was the first 9 months, and it was on a different platform. It was on a WinCE platform. Those gauges right now are not Smart Chart compatible, but we're offering the same discount of 20% if you wanted to trade that one in towards the newer, latest version that is Smart Chart compatible.
Cool. I mean, with everything in Smart Chart too, this was a big deal for us just to combine all of our instrumentation, all the data into one package. So it's good to have PELT as part of that now. Because I think that launched, was it this past November or October? I know it was towards the end of the year.
It was fourth quarter last year. Yeah.
Awesome. When you're talking to customers, are you seeing kind of repeated challenges or mistakes in how they're taking measurements? I know, documenting and, apples to apples, like all of our instruments, it's important to do everything the same exact way, shift to shift, plant to plant. But are there things, that you've seen out there that you can, share with the audience to maybe give them some insight?
Sure. So sometimes, if and this is really when if an operator is first using PELT, it's very important that they know to change the color calibration, make sure you're measuring the right color, because even though you see the waveform and everything looks great, if it's using the math of a different calibration, different calibrated velocity, the thicknesses aren't going to be perfectly accurate. So that is a common mistake in the beginning. Another mistake we see a lot of times is that sometimes we can trap a little bit of water or like a dirt speck or something underneath between the cap and the top of our clear coat, and it gives like a wider kind of crazy looking echo in the front. And we try to tell our customers to slow down, move over just a little bit, just a half of a millimeter over, and make sure that front echo is clean as possible with the least amount of noise. That will give you, the best waveform possible. Some of our old timers, when I say, 3 to 5 seconds for them, that might seem like an eternity. I've seen measurement times where there's 2 seconds between marker placement, waveforms. And I would say that is a bit on the fast side, to always to slow down a little bit and make sure, if you can use your eyes as lasers on that display screen, and if you can mark all those waves with your eyes before you hit capture, then you've got a really good waveform. So those are what I think are the biggest challenges, or the things that we see with operators.
Yeah, and the great thing is, if someone's looking to get into a system like that, I mean, the training that you all provide is just exceptional, and just to make sure it's working for your specific application, and you're getting good clean data and integrating it into other quality systems, or however you're doing your reporting. So good job to the PELT team for that. I've heard a lot of great things.
Thank you. And one of the things that we also say to for a brand new operator, if they're a little bit nervous, the first few times they're taking measurements, or even if it's somebody that's been taking measurements for 20 years. If you come across a job, you've taken all the waveforms and just something just doesn't seem right, or you're scratching your head, save that WAV file, bring it up on the, in the computer, throw it in an email. We are
Yeah.
happy to look at the waves. We will remark them for you. We'll explain why over Teams, kind of go side by side and look at them. Yeah, we really want to make sure everybody's comfortable and happy. We don't want you ever have to make guesses or be worried or concerned. We're here. We're here to help.
No, that's great. That's great. So what other questions, folks? Drop them in the chat here. Also, like I said, you're going to get a recording as soon as we close out this webinar, so you can, scroll through the discussion or the certain points of Renee's presentation on the front end of it. Let's see. What else? Someone who may be considering this, Renee. I think, correct me if I'm wrong, but I think the first step is reach out to you or someone on the team, send us samples, let us do some testing, let us send some data back and start the discussion there and see how we can help improve, overall quality process. Is that right?
Yeah. If you're an automotive customer and this is you're brand new, you haven't seen PELT, we will talk to you about maybe your sister plants or your plastic suppliers. Somebody that around you probably is using PELT, and we can show you some examples and connect you with somebody that can give you their experiences. But if you are a non-automotive customer, we always recommend to send in samples first. Let us take a look at them, give you a feasibility report, set up a meeting, and then we are happy to come out on site, give you a demonstration on how it works, let you and your group, use it, take measurements right there. And that's really the best way. You could, contact me, the marketing team and the sales team. We will get you to the right person.
Oh, that's perfect. That's perfect. Let's see, no other questions. We'll give it another minute here. Maybe everyone get a couple minutes back of their day. But this is really helpful, Renee. This is all pretty new to me anyway. So it's great listening to you and learning, and just thank you for your time and expertise you shared with us today.
Absolutely, my pleasure. Thank you for setting this up.
You bet. We'll have to do this again. Maybe another 5-6 months down the road here. Do a follow up. See how everyone's doing.
Perfect. I look forward to it.
Yeah. So I think with that, we'll release y'all back into the wild. Thanks for joining us today. You'll be getting invites for future Bitgardner web seminars, but thanks for joining us. And again, if you have any questions after the fact, you can simply hit reply to any of the automated marketing messages, and me or my team will route them to Renee or the sales or the technical team over at PELT. So thank you, Renee, and have a great rest of your day, everyone.
Yep. Thank you all. Bye now.